Moving on to the next question. Consider the following reaction. It is forming Q. A, B, C, D are the four structural isomers of the compound Q, and their boiling points vary in their order A, B, C and D. Then the maximum number of possible isomers which may be formed in the bromination of C. So here they didn't mention what C is. We have to find it using the clue point of boiling point. Okay, so first of all, what is this reaction? This will give you the alkanes, right? So you might have seen this reaction in glucose biomolecules chapter. So it will form N-hexane. I'm going to write the isomers of N-hexane because here I'm having 6 carbons. 1, 2, 3, 4, 5, 6. So it will form N-hexane. I'm going to write the isomers of N-hexane. First, it will form a substituted 1, 1, 2, 3, 4, 5, 1. Okay. The another possibility would be like this. This is 2-methyl, this is 3-methyl, and 2,3-methyl also possible. Then I am taking 2,2 dimethyl butane. Okay, so these are the possibilities. Now we are going to arrange it. We are going to name it according to the boiling point. So boiling point is inversely proportional to branching, right? More the branching, less will be the boiling point. So which is having more branching over here? That is our D. That will have a low boiling point, correct? Okay, after that, this is having 2 branching as well compared to other 2. So this makes C, and A and B is not our main concern. If you want, you can go with the interaction repulsion between CH3 group and go about A and B, but only C is our matter of concern. So C, upon doing the bromination, monobromination of C, what I'll get? Let's say the bromination happens over there, this CH3. So CH2Br is my one of those product. In that case, you can see this particular carbon becomes chiral, isn't it? So one side CH2Br, another side CH3, another side this big group and H. So this is chiral. D and L isomers are possible for this. And another possibility of attaching bromine is either of these one carbon. Okay, this is not chiral. So 2 plus 1 equal to 3 is my answer. Okay, so 3 isomers possible for this monobromination of C. Moving on to the next question. Consider the organic compound X shown below. Okay, the compound X is subjected to Geldahl's method for the determination of nitrogen. Ammonia liberated from 2.21 grams of X is. Okay, cool. So which will give you the ammonia? That's what they are talking about. 2 nitrogen is there. I'm taking 2 ammonia. Fine. So here we have to find the molecular mass of this compound to find the moles. The grams is given 2.21. So the molecular formula I'm giving you C10H8N3 okay, Cl and O. Okay, so from this you can find out the molecular mass, that is 221. So the number of moles of taken, that is given mass by molecular mass, which will become 0.01. Here 2 moles of ammonium has been produced from amine, so which will become into 2. That will give you the number of moles of ammonia. So from here we have to find out the mass. So one mass of ammonia, molecular mass of ammonia, that is 17. So mass of ammonia, which is 17 into 0.02, nothing but 0.34. Okay, so 0.34 is my answer. Cool. Moving on to the next question. X, Y and Z are atoms of 3 non-metallic elements belonging to period 2 of the modern periodic table. Okay, period 2. Fine. The relative variations of the covalent radius, first ionization enthalpy, electron affinity is given. Okay. the atomic number of X, Y and Z are in n minus 1, n plus 1 respectively, which means that these are the atoms, the subsequent atoms. Okay. So according to this, we have to find out the value of n is. N is nothing but the atomic number, right? Okay. So first, let's see what are the elements we have in period 2. We have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Fine. So the first one talking about covalent radius. Covalent radius increases as we move left to right in the period. Cool. So if I'm moving left to right, it will, decreases, right? Decreases. So they have given Z, Y and X. They are in the order. So the least one is Z and highest one, that is X. Okay. Then they are talking about first ionization enthalpy. So first ionization enthalpy means you have to consider the fully filled and half filled orbitals as well. Because from there, the removal of electron becomes tougher, difficult. Okay. So in that case, the order you can see Z is greater than X and then Y. So there will be a difference. There is not a perfect order is followed from taking from the covalent radius. So in that case, I'm putting on hold. Then moving on to electron affinity. That is following an order X, Y and Z. Great. So Z is having more. So this is increases. Fine. So only clue point here we have, that is ionization enthalpy. So you can see this nitrogen, oxygen and fluorine. Nitrogen is having 2p3 configuration. So which will need more electron to be removed. Sorry, I made a mistake. 2p3 configuration. So nitrogen is that will need more energy to lose an electron. Okay. So according to that, fluorine, then comes nitrogen, then comes oxygen. That would be our order. So fluorine is Z, then X, that is nitrogen least, then Y. Okay, sorted. So which means these three are our concern. So n minus 1, that is nitrogen, n is oxygen, n plus 1, that is fluorine. So what is the value of n? N is 8. So 8 is your answer. Okay, clear? Moving on to the next question. This is a comprehension type question. The following reaction scheme describes the conversion of P to R, S to U. The compound P has 2 primary carbon atoms and the molar mass difference between S and T, that is 169 gram per mole. S and T. Okay. So first let's see what is the first question. Treating R with excess of ammonia gives compound X. Starting 3 moles of R produced. Okay. It relates organic chemistry with mole concept. So here R I want. First I have to derive R. C7H16. So C7H16. It is undergoing Cr2O3. What is this reagent? This reagent is used for aromatization. Right, here I am having 7 carbons, so it can possibly form toluene. Right, first it will form toluene from alkane. Okay, toluene. Then the next reaction, Cl2, the presence of heat, 3 equivalent. Okay, 3 equivalent, which means the hydrogen will be substituted by Cl. Then H2O. H2O, all Cl will be replaced by OH. That is not a stable compound at all. So immediately that will undergo the elimination of water. This will produce COOH. Right? After that, lithium aluminum hydrate, isn't it? That is a good reducing agent. It converts to alcohol, primary alcohol. Then that is our Q. Okay, great. This is Q. So Q is treated with, what is this? It is this big molecule. Pyridine, right? What is this chloride, chromium compound? This is PCC, right? So sometimes they will give you in type of structure as well. So PCC. PCC, what that will do? That will oxidize, mild oxidizing agent, isn't it? So primary alcohol to aldehyde group. So this is our R, major product as R. Okay. So what is the question? Treating R with excess ammonia gives X. Treating R with excess ammonia. That is the main point over here. Excess ammonia. They didn't mention any amount. That is excess ammonia starting with 3 moles of R. So we are starting with 3 moles of R. So I'm going to take 3 R molecule. So what is this reaction first of all? So this will take up oxygen from aldehyde and hydrogen from NH3 to form a combined compound, right? So let me take it like this, PHCH4. So I'm taking 3 moles of this compound. And with excess of ammonia. It will remove the water molecules and form PH, CH with double bond N. Put it over here. CH, N, PHC, H. Okay, so this is sorted. What they are asking, 3 moles of R, the amount of X produced in grams. Okay, so here I'm having the total molecular mass will become 298. So 298 is its molecular mass. So 3 moles of R gives 1 mole of this compound. So 1 mass, total mass will become 1 into 298, which turns out to be 298 as your answer. Okay. Then the next question is talking about R reacts with U to form colored crystalline compound Z. The number of hydrogen atoms bonded to sp2 hybridized carbon in Z is X. The degree of unsaturation of Z is Y. The value of X plus Y. So first of all, R reacts with U. So what is U over here? U is the second reaction. So the first one is bromination. Second one is nitration. Nitration followed by hydrazine and ETOH, ethanol. So which will form U. Let's see what that is. So I'm having benzene with bromination that will produce bromobenzene. Then nitration that will produce bromine is a deactivates the ring but orthopara substitute. So which will produce ortho and para product. Correct? So this is undergoing, this is T and this is undergoing the reaction with N2H4 hydrazine. So that will interact with our bromine. So that will replace our bromine. Nitro group remains the same. This is our U. So the question is R reacts with U. R is benzaldehyde reacts with U, that is having NH2 compound, crystalline compound Z. The number of hydrogen atoms bonded to sp2 hybridized atoms, Z is. Okay, so here we need to know what Z is. So I'm writing it like this: pH, CH, it will take up the water with the release of water, double bond, N, with NH, which is connected to our nitro group. Okay, so fine. So degree of unsaturation of Z. Okay, so how many degree of unsaturation is here? So here I'm having a phenyl ring. So that will give you 4 plus double bond is there, and then this side I'm having one phenyl ring and 2 nitro group is there. So which will be connected like this, isn't it? So that will give you 2. So total 4 plus 4 plus 3, 8 plus 3, 11. So 11 is Y. What about X? sp2 hybridized carbon atoms. So if you are counting sp2 hybridized carbon atoms, here this side I'm having 5 and another side 1, 2, 3, 5. So total I'll be having sp2 hybridized carbon. Okay, 1, 2, 3, 4 only. Fine. So 5 plus 4, 9. So 9 is X. So X plus Y value, which will become 20. So 20 is your answer. Okay. Then let's see the last question of the sample paper. When 100 ml of 1 molar HCl is mixed with 1 molar of NaOH, that is also 100 ml. The temperature change, that is 5.7 in the first experiment. Second experiment, here we have 2 molar of acetic acid, 1 molar of NaOH, and the temperature rises 5.6. So heat capacity of all the solution is 4.2 and the density is 1. Cool. So let's calculate what? Enthalpy of dissociation of acetic acid obtained, that is number 1 question, and the second question is pH of the solution. Cool. So the first, let's calculate the heat absorbed by the solution. Heat absorbed. And considering the experiment 1. Okay, so from that only we are able to calculate the calorimeter constant. So heat absorbed, MC delta T. Right? Okay, so here I'm having the mass as 100 ml, 100 ml. So density is 1, so 200. 200 into 4.2, that is a specific heat capacity given, into the temperature change of first experiment is 5.7 degrees Celsius. So overall I'll get 4788 joules. So they have mentioned that neutralization of strong acid with a strong base at constant enthalpy of neutralization is minus 57 kilojoule. So total heat absorbed will become 50,100 minus 4,788, which will become minus 912 joules. Okay, so the calorimeter constant, that is minus 912 divided by 5.7, that is our temperature change, which will give you 160 joule per Kelvin. Right. Okay, now we are moving on to the experiment 2. So experiment 2, we have 0.2 moles of acetic acid and 0.1 mole of NaOH. Okay, and the temperature rise is 5.6, that is the difference. So heat absorbed, once again, the density is same. So 200 into 4.2, 5.6, which will 4704. So the total heat absorbed by the calorimeter 5,700, that is for experiment 1. Here I have 4704. So I found the calorimetric constant as 160, right? So 160 minus 160 by 5.6 is the temperature change over here. That is 896 as your heat observed by the calorimeter. So the total heat released, which will become 4704 plus 896 equal to 5600. We have given that is 57 kilojoule, which means 5700 joules. So 5700 joules so the enthalpy of dissociation equal to the enthalpy of strong acid minus enthalpy of weak acid, right? So minus 57, and here I'm having minus 56, right? These are in kilojoules, okay? So remaining I'll get minus 1 kilojoule per mole. So they are asking it in kilojoule per mole, so answer to this question is 1. Okay, so and the next question is, what is the pH of the solution after experiment 2? Experiment 2, n into 10 to the power minus 1, the value of n they are asking. So pH, which is equal to pKa. So what is pKa? Log Ka minus log Ka. What is Ka value over here? What is the change? That is 2.0 into 10 to the power minus 5. So I'm just substituting the values. Minus log 2.2 into 10 to the power 5. So by solving this, 5 log 2 will become 0.3. So 5 minus 0.3, that is 4.7. So 4.7, here they are mentioning it as n into 10 to the power minus 1. So 47 into 10 to the power minus 1. So 47 is your answer. Okay, cool. So these are the questions which are there in the sample paper. So we'll create more videos on block chemistry, and what else videos you want for the concept clarification on the questions, let me know in the comments. Keep practicing more and more questions. Keep motivated. Thank you.